Alright, Assalamu alaikum. This is Talha bin Nadeem, and uh, this is the second recorded video lecture of the topic mechanical injection system. In the last recorded video lecture, we started the new topic of injection system, mechanical injection system. Then we did some brief introduction that what is the purpose and why the mechanical injection systems are required in CI engines. Then we discussed that in SI engine we have a carburetor which is preparing air fuel mixture. Then it is sending that air fuel mixture into the combustion chamber for combustion. But in fuel injection systems, we do not have carburetor, and we are not sending air fuel mixture in the combustion chamber. Rather, we are only entering the air, and air is being compressed. Then at the end of compression stroke, we inject the fuel with the help of fuel injection system. Then we discuss some of the differences between the carburetor and fuel injector system, that in carburetor air speed is greater, which is taking the fuel from the float chamber and also atomizing it, then thus making a air fuel mixture, homogeneous air fuel mixture. But in fuel injectors, fuel speed is greater than the air speed at the point of the delivery, and that is why the fuel is being atomized. Similarly, we also discussed that in carburetors, air velocity is responsible for the amount of a fuel being taken from float chamber to the combustion chamber. That when the air speed is greater or pressure drop is greater, pressure drop is referred as carburetor depression is greater, thus the large amount of the fuel would be taken in and then being sent to the combustion chamber. On the other hand, in fuel injectors, we have the amount of a fuel is being controlled by a external pump. Then we studied some of the functional requirements of the injector system, which were: first one was the accurate metering, timely injection of the fuel, then proper controlling of rate of injection, atomization. Fifth one was proper spray pattern. I explained that part earlier, that if the spray patterns are not uniformly distributed, then you will not have the air fuel homogeneous, a mixture which is close to homogeneous. So we must have a proper spray pattern, like as I explained in the last video tutorial, that for example this is your two combustion chambers, and one is this spray pattern and other is this spray pattern. In the second one, larger surface area is being covered, and therefore it has this arrangement too has more tendency to make a mixture which is more close to the homogeneous mixture as compared to the first arrangement. Well, now and then we discussed about the uniform distribution of the droplets, which I explained in the by drawing the two different combustion chamber with the different spray patterns. Then it also has to ensure that the equal amount of the fuel is being supplied if we have a multi-cylinder engine. And then I discussed about there should be no lag and between the starting point of the fuel injection and the ending point of the fuel injection, and it should not have some dribbling. There shouldn't be any dribbling of the fuel as well, and I explained this dribbling effect as well in the last video lecture as well. Then we discussed the two main classifications of the injection system. First one was the air injection system, and second was the solid injection system. And I mentioned in the last video tutorial as well that we will discuss the solid injection system in details, and we will not study the air injection system in that much detail because they are being obsolete and they are not being used nowadays. And then we started off with the air injection system, brief introduction of the air injection system. We discussed some of the advantages, and we also discussed the disadvantage of this air injection system, and thus concluding that because of the bulky size of their multi-stage compressors, these injection systems are being obsolete nowadays, and mechanical injection systems are more commonly being used. Then we discussed that this solid injection systems are sometimes also referred as airless mechanical injection system, and because air is not being used in these injection system for the compression of the for pressurizing the fuel. Then I mentioned that there are 4 different configurations which are being used for the solid injection systems, but I didn't discuss the details of these injection systems, and I told you in the last video lecture that I will explain these different arrangements in today's video lecture. So we will start the video lecture from here, from these 4 topics. After that we studied the main components of the mechanical injection system, and we concluded that we have 6 main components: fuel tank, fuel feed pump, injection pump, governor, mechanical injectors, and we have fuel filters. And I also explained that we will discuss these 4 components in quite some details in this video lecture and in the next video lecture as well. Then we move towards the schematic of this schematic of the mechanical injection system, most common schematic diagram of the mechanical injection system, and I explained this diagram in quite details, and after that I explained the working of this mechanical injection system. So now we ended our last video lecture at this point. Today I will start explaining these 4 different arrangements. First one is individual pump and nozzle systems. Now here you can see this is the schematic of the individual pump and nozzle system. Here you can see that for each cylinder, this is a 2-cylinder engine. For each cylinder there is an injector, and there is a separate high pressure pump, or you can say injection pump. We said that we have 2 pumps, one is fuel feed pump and the other one is injection pump. So injection pump is the high pressure pump. This is injection pumps, and we have separate injection pumps for each cylinder. Then here we have the low pressure pump, which is sending the fuel from the fuel feed tank. This is our fuel feed pump. So by looking at this schematic, we can say that why this arrangement is known as the individual pump and nozzle system, because for each cylinder we have a separate injection pump and the nozzle system as well, and the fuel injector, or you can say fuel injector as well. Okay, so that is why this sort of a arrangement is known as individual pump and nozzle system. In the next schematic, this is also an arrangement for individual pump and nozzle system, and here you can see that we have a separate injector for each of the cylinders, and here you can see that we have separate high pressure pumps as well, but the difference is these pumps are arranged in a form of a cluster. They are being arranged together. This is the only difference between these two arrangements. We can have these arrangements, either the first one or maybe the second one. We can have separate pumps on each of the cylinders, or we can have a cluster of a pump placed below the near the cylinders, to which will be pressurizing the fuel coming from the fuel feed pumps. I hope it is clear now. The function is same, the operation is same, the only difference is of the arrangement of high pressure pumps. So we can simply conclude by saying that when the different cylinders have their own injection pump and injector, then this sort of arrangement is called individual pump and nozzle system arrangement. In this system, each cylinder is provided with one pump and one injector. I have explained this part. In this arrangement, a separate metering and compression pump is provided for each cylinder. Okay, here you can see that separate pump is provided for the metering of the fuel, means the fuel metering, the controlling of the fuel here is being done by this high pressure pumps. Fuel metering is done by these high pressure pumps. The pump may be placed close to the cylinder as shown in the figure A, or may be placed in the form of a cluster as shown in figure B. Means we can use both of these arrangements. Your IC engine can either have a first arrangement or the second arrangement, but they would be called individual pump and nozzle system, since the pump and injectors are different for each of the cylinder. These high pressure pump plungers are actuated by a cam. There is a camshaft which will be operating these pumps, these high pressure pump. When I would be discussing these high pressure pumps, then you will come to know that how the cam is operating these high pressure pumps. And these high pressure pumps would be producing that much amount of the pressure. They would be pressurizing the fuel to that extent that they would be opening the outlet valves of these injectors, and then the fuel would be injected into the combustion chamber when it is required. Now here it is one different thing, one very important thing that the amount of the fuel is dependent on the effective stroke of this plunger type pump. I will explain this effective stroke when I will be explaining the injection pumps in details, maybe in this video lecture or maybe in the next video lecture. So here we all know that what would be the stroke. Means for example, if you have a plunger and that plunger is moving from this bottom dead center to this top dead center, this will be called stroke, and your plunger would be moving between these two maximum and minimum dead center, bottom and top dead center. But what do we mean by an effective stroke? I will explain this part in the later topic when we will be discussing the high pressure the injection pumps in details. So far we can conclude by saying that the amount of the fuel is dependent on the effective stroke of this plunger pump, of this high pressure plunger pump. I'm underlining it so that when I will come to that part I will explain this. Now moving towards the next arrangement. Moving towards the next arrangement, and it is of the unit injector system. When we come towards this schematic, here we can see that now the high pressure pumps are not shown in this section. In this section there are no high pressure pumps. Rather we can see here that on the top we do not only have the injectors, but we also have the high pressure pumps as well. There is a low pressure pump at the bottom, but we do not have any high pressure pump here, which were present in the first arrangement. So in this unit injector system, as the name suggests, by the unit we mean single one. So we have a single housing which consists of a high pressure pump and the injector, and that housing would be placed on the top of the cylinder and the pump would be pressurizing the fuel that much amount, to that extent that it will open the outlet valve of the injector and then being injected into the combustion chamber. So we can say that we can say that we have here, we not only have injectors, we also have the high pressure pump as well in this complete housing. I hope this is clear now. So what is the difference between the first arrangement? Pump and the injectors are placed separately, and in the unit injector they are being placed in a single housing and being placed on the top of the cylinder. So a unit injector system is one in which the pump and the injector nozzle are combined in one housing. Each cylinder is provided with one of these units, one of these housing. You can see we have two cylinders in this schematic, and we have two different housing, for one each for the one each for the cylinder. Fuel is brought up to the injector by a low pressure feed pump, where at a proper time a rocker arm actuates the plunger and thus injects the fuel into the cylinder. The low pressure pump would be taking the fuel to this housing, where the high pressure pump will pressurize it to that extent that it will open the outlet valve of the injector, fuel injector, and then being injected into the combustion chamber. Here again, this is the same thing, that amount of a fuel injected is dependent on the effective stroke. I will again effective stroke of the high pressure pump. I will explain this part in the later, as I mentioned earlier. I will explain this in the later topic of this video tutorial. The pump and injectors can be integrated in one unit as shown in figure C. I hope the difference between the two arrangement is quite clear now. In individual pump and nozzle system we have a separate pump and injector, and in unit injector system we have separate we have a single housing for high pressure pump and fuel injector. Then we have a common rail system. Third arrangement was common rail system. Now here you can see this is the schematic of the common rail system. Here you can see that this is your high pressure pump. You do not have different high pressure pump for individual cylinders. Rather we have only single high pressure pump, and that high pressure pump is taking that high pressurized fuel into a common header. This is your common header. All the high pressurized fuel is present in this common header. Then this common header would be taking the fuel to the individual injectors present at the top of each cylinder. They are high pressurized line, and they are taking the fuel, high pressurized fuel to the top of the to the injector, which are present on the top of the cylinders, each cylinders. Now here one important thing to understand is that all the lines, for example if we have two cylinder or 4 cylinder or maybe 6 cylinder, all the injectors in each of the cylinder are getting the pressurized fuel from this common header. And if when the fuel is going from this common header, the pressure is dropping inside the header, and high pressure pump is then sending the pressurized fuel in this common header to maintain the pressure, so that the fuel is being taken from this header to the injectors on the top. So we do not have individual pumps in this arrangement. Rather we just have a common system, common header, from which the fuel is being taken into individual injectors. So this is the main difference between the previous two arrangement and this arrangement, that we do not have individual pumps for each cylinder. We have a single pump which is pressurizing the fuel to that much amount and being stored in the header, and from that header the fuel is being taken into the injectors and then injected into the combustion chamber, and so on. I hope it is clear now. In common rail system, a high pressure pump system supplies fuel to a fuel header. High pressure in the header forces the fuel to each nozzles located on the top of the cylinder. Fuel is being stored in this header. Then from these high pressure line, it is being sent to the injector, where the fuel would be injected, from which the fuel would be injected into the combustion chamber. Now at a proper time, a mechanically operated, by the word mechanically operated we mean that by push rod and the rocker arm, the valve allows the fuel to enter the proper cylinder through nozzle. This is the entire operation of the injector system. I will explain these components when I would be explaining the fuel injectors. I mentioned that I will explain the 4 components in details of this injection system: fuel feed pump, injection pump, governors, and fuel injectors. I will explain the effective stroke part when I would be explaining the second topic of the injection pump. I will explain all these components of the injectors in the 4th topic when I would be discussing the details of this fuel injectors. That where the nozzle is present, what are the inlet and outlet valve, from where the inlet of the fuel would be coming, and from where the outlet would be injected into the combustion chamber. I will explain all of these parts in the later classes. The pressure in the fuel header must be that much for which the injector system was designed. By this it means that, for example, your fuel injector is to be operated on 150 bars, for example. So your high pressure pump should have pressurized the fuel to that much extent that it should overcome all the pressure losses from when it is being traveled from that high pressure pump to the top of the cylinder. Let's say the pressure loss during this much distance is of 1 bar. So your high pressure pump should pressurize the fuel up to 151 bar, so that when it reaches the top of the cylinder, it gets pressure of 150 bar. Let's say we require pressure of 150 bar in these fuel injectors at these points. So, and there must be some friction losses in these high pressure lines and in this common header as well. So your pressure, let's say that pressure drop is around 1 bar. So your fuel should be operating at 151 bar. If your nozzle system is designed to operate at 150 bar, your fuel should pressurize the fuel to that much extent that it should overcome all the pressure losses, all the friction losses from when it so that the fuel, when traveled from this point to this point where the injectors are, all the pressure loss, all the friction losses are overcome. And it should also be enabled to penetrate and disperse the fuel into the combustion chamber as well. I have explained this part as well, that fuel should be penetrated throughout the combustion chamber and should be sprayed across the combustion chamber. So your fuel should be pressurized that much by this high pressure pump. And it is applicable for all the previous arrangements as well, that it should be enabled to pressurize the fuel to that extent that we do not have for which the your injectors are basically designed. Your high pressure pump should be enabled to pressurize the fuel up to that point. Okay, here again the amount of a fuel entering is again dependent on the length of the push rod stroke. This is again the thing which I will explain, that how the amount of the fuel are being controlled by these high pressure pumps. So okay, but no, in this arrangement it is not being controlled by the high pressure pumps, rather they are being controlled by the length of the push rods, means they are being controlled by the injector system mechanism. So this is again the difference between the previous 2 arrangement and this arrangement as well, that the length of the push rod stroke is being is controlling the amount of the fuel which is entering into the combustion chamber, not the high pressure pump. In the previous two, high pressure pump was controlling it, but in this arrangement the length of the push rods of the injectors are controlling it. The high pressure pump is used for supplying the fuel to a header from where the fuel is metered by the injectors. This is what I was trying to explain, that in the previous two arrangement metering was done by the high pressure pump. In this arrangement the metering is done by the injectors only, not by the high pressure pump. Next we have the distributor system. This is the last configuration, this is the last arrangement which are most commonly being used for the injector systems, mechanical injector systems. Here you can see this is the schematic of the distributor system. This is your distributor. The fuel is being pressurized and then being sent to this distributor, and when it is required, this fuel is being pressurized to that extent that it will take the fuel from this point to the top of the cylinder where the injectors are present. But fuel would only be going when I will this is your rotor, and this is your barrel. Barrel is stationary component, and this rotor is rotating component, and we have some slots in these rotors as well. When this slot is aligned with this line, then in the cylinder that time has arrived when the fuel is about to be injected. So the fuel will go through this high pressure line into the fuel injector, and then being injected into the cylinder. Similarly, when this rotor is rotating, and it is rotating, and when it comes in alignment with this cylinder, so now the injection time has started, and fuel will travel from here to this point where the fuel would be injected into the combustion chamber. So this is how these distributor systems are operating. Fuel is just being pressurized by the high pressure pump. Then the distributor pump is responsible. Then this distributor system is responsible for supplying the fuel to each of the cylinders. In this system, pump which pressurizes the fuel is also metering, and not only metering but also timing it as well. The fuel pump, after metering the required amount of fuel, supplies it to the rotating distributor, and when the correct time has arrived, it will supply, that distributor will now supply the fuel to the fuel injectors. Pump has pressurized it and then supplied to the distributor, and when that rotor comes for example, this is your rotor is rotating, and this is the outlet line from which the fuel will go to the injector. This is the arrangement, this is the passage from which the fuel will come, and it is rotating, and when it comes in alignment with this outlet passage, the fuel will pass to the injectors for fuel injection. And when the rotor has passed through this point, no fuel would be supplied to that cylinder. And when it comes with the in alignment with the passage of the second cylinder, then the fuel would be sent to the second cylinder. I hope it is clear now. The rotation of the rotor in the distributor system is basically responsible for supplying the fuel to the injectors. Pump is only pressurizing it and metering it. The number of injection strokes per cycle for the pump is equal to the number of cylinders. Since there is only one metering element in this arrangement, uniform distribution is automatically ensured to each of the cylinders, because fuel is only being pumped by the high pressure pump, which is sending the fuel to the distributor. But in the previous arrangements we had the separate fuel injection pumps for each of the cylinder. Therefore, ensuring that the same amount of the fuel is being supplied to each cylinder is not an easy task. But since we have only single fuel pump, injection pump in this arrangement, then we can say that the same amount of the fuel would be supplying the same amount of a fuel to each of the cylinders. And not only that, since only single fuel pump is being used, the cost of this system is also reduced, and they are quite simple as well. Their arrangement is not quite difficult since we have only one single pump. So these arrangements are most commonly used in our IC engines, in our cars. Distributor systems are most commonly being used. This is the comparison of the various fuel injection system which we have studied till far. I have explained all these things in details, so I will not go into the details of this table. I will expect that you guys will relate all the theoretical discussion which I have done in half an hour, and you can relate that discussion with this table. So make sure this is just the summary of what we have studied so far. So make sure that you guys study it.